long as your angle has a denominator that you are familiar with, all you have to do is either add or subtract to get it on your unit circle. All the way around our unit circle is 2 pi, right? That's one revolution around our unit circle. So if you had an angle that's too big, which 8 pi over 3 is too big, or an angle that's too small, like a negative angle, you're just going to add or subtract until you get on the unit circle. So here's what that's going to look like. For 8 pi over 3, what 8 pi over 3 would look like, I'm going to show you what that angle would look like. And if you totally hate it, you can forget that it happened, okay? Because some of you are going to be okay, and some of you are going to be like, she just broke me. Okay, let's talk about in thirds. Pi is 3 pi over 3, right? And 2 pi is 6 pi over 3. So 8 pi over 3 does this, because this really is a circle that goes around, like we're just going around it forever. So it would be all the way around would be 2 pi, which is the same as 6 pi over 3. And then how many more to get to 8? How many more thirds? 2. So 1 pi over 3 is there, right? And 2 pi over 3 is here. So this angle is on the same line as 2 pi over 3. It just spirals around like that. It's that same spot. It's the same angle. It's just spiraled around an extra. The negatives spiral the other way. It's nice to know that. You don't particularly have to know that. You have to know how to work with it. And so basically how we unspiral this to figure out where 8 pi over 3 really lives, which quadrant it is just by subtracting 2 pi. So here's what your work looks like. 8 pi over 3 minus 2 pi to get it onto our unit circle. But we need a common denominator. So our common denominator, what am I going to multiply 2 pi over 1 by? 3 over 3, absolutely. So that's 8 pi over 3 minus 6 pi over 3. And 8 minus 6 is 2. Our coterminal angle, and really back when, I don't know if you guys did any of the terminology in Algebra 2, when you talked about angles, it's like the initial side of your angle, and then the terminal side of your angle is the one that actually makes the angle. Yep, there's my interpretive peanuts. You're welcome. Here's this back. So coterminal just means it has the same terminal side, same angle. And now we can do all of our sine, cosine, tangent, and the reciprocal values. So I think in your guys' packet you have these typed out because I got tired of writing them and then I didn't snag that for up here. So I'm still going to say that this is sine of 8 pi over 3 because that's what we're finding. It's just the same as sine of 2 pi over 3. So what is sine at 2 pi over 3? So at all of our, remember the way I like to work with this, and you might, hopefully you do too, I like to think of sine at pi over 3. Sine at pi over 3 is radical 3 over 2. And then 2 pi over 3 is in which quadrant? The second quadrant. And in the second quadrant, sine is positive. And in the second quadrant, cosine and tangent are going to be negative. The reference angle we were working with there is pi over 3. Again, if you guys don't like this text box, really the only thing that's really important here is that coterminal angle. So cosine of 8 pi over 3 and 2 pi over 3 is going to be 1/2, because sine is radical 3 over 2. And since we're in quadrant 2, cosine is negative. Tangent. What's tangent at all of our pi over 3s?
Sine of x.
Yep, sine divided by cosine. Also, at all of our thirds, it's radical 3, and we're going to have a negative there. The other 3, cosecant is the pair with sine. It's the reciprocal. When I do this for you on the test, I'm not trying to trick you. Unless I make a terrible typo. I'm lining them up for you. Okay, on a problem like this. Cosecant is sine's reciprocal. I'm going to flip 2 over radical 3. I'm going to flip radical 3 over 2 to be 2 over radical 3. And then I'm going to rationalize. Secant is cosine's reciprocal. The other reason that I typed these out for you is I don't want you to get in the habit of not putting an angle value in there, like not putting 8 pi over 3 or even 2 pi over 3 in there, because just SEC, secant, that's just like saying multiply. Like it all on its own doesn't mean anything. You have to have an angle value in there, or a variable if you want. So when I flip negative 1/2, I get negative 2. I'm going to write it as negative 2 over 1 to preserve that situation. And cotangent of 8 pi over 3. When I flip, what do I get when I flip negative radical 3? Awesome. Negative square root of 3 over 3. Once I rationalize. I can't leave this ordered pair over here. This was negative 1/2, radical 3 over 2. You can leave it if you're using it. I just feel that anything like that. So your first step, if you look at this angle, and it is not on your unit circle, it's not one of your unit circle angles, the first step is to get it on your unit circle, make it into one of them. And what we're doing is adding or subtracting 2 pi. 17 pi over 6. Great.
17 pi is 23.
Yours is 23. All right. Is it 23 pi over 6?
Yep.
Yeah. Cool. All right. What are we subtracting? We're subtracting 2 pi. But what is 2 pi in 6?
12 pi over 6.
Awesome. This is more interesting. What do I get when I subtract 12 pi over 6 from 23 pi over 6? How many? 11 pi over 6. Is that on our unit circle?
Yes.
Yes. Awesome. So 23 pi over 6 is just, here, this would be 24. That would be 12 pi over 6. So we're wrapped all the way around 12, and then all the way around 11 more. The other angle that would be coterminal with that, another way we could write that this way as negative pi over 6. Negative angles go the opposite direction. And I'll do one of those in a minute, if I'm remembering correctly. So we're going to do all of this for 11 pi over 6. Ready, go. I'll catch up with you.
I think I'm done. I might not be, but I think I'm done.
my work?
One beer.
I had an extra caffeinated beverage this morning, which is not always 100% productive. It's delicious, but.
Coffee.
All right, flip your paper. Let's do a quadrantal. Let's do a quadrantal that's negative, and then we'll come back to 3 and 4. Do you guys have negative 5, 5 somewhere?
Yes.
Let's do a negative. I think I have that one up here too. I'm going to do a quadrantal though, so we can talk about those undefined values, and then I'll let you practice with the other two if we have time through the short period today. So negative 5 pi, here's what that looks like, just so you have the visual on a positive and a negative angle. So we have 0, we have pi, we have 2 pi, and really any rotation that you do, odds are going to end up over here at pi, of whole pi's, and evens are going to end up here at 2 pi. If we're going to rotate negatively, again, we're going to go clockwise rather than counterclockwise. So we'd start here at 0. Negative pi would be here, just wrapped this direction. And if we're going to keep going, so this would be 2 pi, 3 pi, 4 pi, 5 pi. So that guy is negative 5 pi, and negative 3 pi, and positive 5 pi. And if those spirals break your brain, you're going to pretend like it didn't happen. It doesn't really matter. You're doing the math for it when you're adding 2 pi. Now here, you don't have to get a common denominator. So the math behind this, what happens when I do negative 5 pi plus 2 pi? What do I get? Negative 3 pi. Am I on the unit circle yet? Is that between 0 and 2 pi yet? Nope. Okay, we're going to keep going then. And you have to do this sometimes. It depends on how interesting I decided to make the problem, how many times you have to add or subtract 2 pi. What's negative 3 pi plus 2 pi?
Negative pi.
Negative pi. On the unit circle yet? I mean, kind of, but not really, right? We're going to add 2 pi again, and we're going to get pi. Our coterminal angle is pi. I think it's kind of helpful to be able to visualize where you are with those rotations, but it's not 100% necessary. So if the spirals, if you're like, oh, I like the spirals, I just want to draw it, that's wonderful. If the spirals, if you do not dig the spirals up there on the unit circle, again, just ignore. This really isn't in a quadrant, this is a quadrantal angle. I have been accused of making up that word before. I did not make it up. Let's see. Cosine is negative there, and the positive and negatives really don't, like, because since we have 0, I know cosine is definitely negative. We don't really have a reference angle. So here we're just dealing with pi. So sine of negative 5 pi. What is sine of pi? How many am I going up to get to pi?
0.
0. Cosine at negative 5 pi. How many am I going over?
Negative 1.
Negative 1. This is the order that I like, sine and then cosine, because I can see tangent then, because I just see 0 over negative 1 is 0. You have to be careful, and I tried to yesterday when you guys were working on the tray table to double check this for you. If sine is 0, cosecant is undefined. Because when we're flipping 0, you have to imagine 0 going from the numerator to the denominator now. So cosecant isn't 0, cosecant is undefined. What is secant? Yeah. When you flip negative 1, you just get negative 1. And tangent, really, I think is a little easier because you have that ratio that you can be looking at, 0 over negative 1. So cotangent, if tangent is 0, cotangent is going to be undefined. All right. Your question.